Hey everybody, this is Philip Moore from Gizmo Data. Today I want to be talking about our composable data engine GizmoSQL. So GizmoSQL is a composable engine built from components like DuckDB as a backend data engine and Aeroflight SQL as an intermediary server to allow you to run DuckDB remotely. So GizmoSQL also provides enterprise-grade security so that you can run it securely on the internet in the cloud, talk to it securely from your laptop or a Jupyter notebook or whatever client you want to use. Because it's Aeroflight SQL, you have the benefit of JDBC driver and the new ADBC driver and even ODBC. It's compatible with almost anything that has one of those three connection capabilities, which is pretty much every client product on the market today. So GizmoSQL, because it leverages the DuckDB engine, is lightning fast. If you're using a distributed system today to run enterprise queries for multiple users, you're probably overpaying for most distributed systems. And to be honest, distributed systems are actually overkill for a lot of data footprints that are probably 5 terabytes and smaller. If you have more than 5 terabytes, by all means, keep using distributed systems. But if you have less data than that in your enterprise data warehouse, GizmoSQL is a perfect solution for you because you can ingest that data onto a VM's local NVMe solid state storage and run lightning fast queries concurrently from multiple users securely with great performance and with great concurrency. So today I'm going to be demonstrating how to run a GizmoSQL server, and then we're going to actually get crazy and we're going to run TPCH scale factor 100 gigabytes, 1.21 gigabit, sorry, and then we're going to turn it up a notch further, and we're going to run 10 of those concurrently at the same time. And I know concurrently means at the same time, so that's a little bit superfluous, but anyway. All right, so let's get going. As you can see here on my screen, I've started a VM here. I'm actually in the prompt, but let me show you. Let's take a step back, and I'll show you what the VM looks like here. So I'm running an Azure benchmarking virtual machine. So this is a standard E64 PDS v6. So what does that PDS stand for? Well, that means that it has local NVMe solid state storage. So this bad boy has 3.3 terabytes of NVMe on it. And it has 64 CPUs and 512 gigabytes of memory. It's an enterprise class machine. And how much does it cost? It costs $3.74 per hour. So it's dirt cheap to run an enterprise class VM in Azure. And of course, if you run in AWS, you have equivalent options in GCP as well. The cool thing is this VM is ARM64 based processor. So it's going to run cheaper and more power efficient and faster than the x86 equivalent. So in Azure, these are called Cobalt 100s, and in AWS they call them Gravitons. Latest is Graviton 4, I believe. And I forget what GCP calls theirs, but we'll come back to it in a minute. So this guy is running right now, and we have lots of resources available to us. Let's take full advantage of them. All right, so back here on this machine, if we'll go to the data directory, and this is where we've mounted that NVMe storage. So we have mounted that storage to a directory called opt GizmoSQL data. And you can see the size, total size is 3.4 terabytes, and we've got 3.2 terabytes free on this. So let's take a look at the contents. We have a database, a DuckDB database file, and it's pretty small here. It's just basically a bunch of views on top of Parquet data sets. So in this TPCH folder, we'll go in there and scale factor 100 directory, and you can see we have a folder for each table in the TPCH data set. So let's go into the line item table, and you can see there's a bunch of Parquet files, roughly on average around 99 megabytes in size. So there's quite a few of these. I think there's like 755. So if I do a word count on that, you can see, actually, I'm sorry, there's only 177 files. I was thinking the scale factor 1000. So there's quite a bit of data in here, but GizmoSQL, by virtue of having the DuckDB engine, can slice right through that. And then by virtue of having Aeroflight SQL, we can connect remotely to this machine and run queries concurrently. All right, so we haven't started our server yet, Let's go ahead and start that. So if I go here to our launch script, the first thing you do is to create some TLS certificates. That encrypts the traffic to and from the server. That's essential because you don't want somebody sniffing that traffic going between your client on your laptop, for example, and the cloud, because they could get your password, they could get sensitive data that would be traveling. So TLS will encrypt that traffic and make it impossible for them to decrypt it unless they have a quantum computer and they're a trillionaire. We will go ahead and launch our Gizmo SQL server. We're going to put it on port 443, and so it's going to be open to the internet. And we're going to do data launch with database file name data TPCH scale factor 100.db. Connect with username Scott. We're going to use these TLS certificates to encrypt the traffic. We're going to print queries that come in from clients, and finally we're going to launch with our license for Gizmo SQL. All right, so let's try it and launch that bad boy. And as you can see, we've launched Gizmo SQL with our license here. It's using Apache Arrow version 18.1, DuckDB 1.1.3. Launches some commands to allow us to install extensions without having to approve them. We've launched with that database file. We're printing out our queries, and we're ready to rock and roll. So let's go ahead and we will connect to our instance here. So you can see I'm in PyCharm. This is running in the cloud, but this is on my laptop. And we have a console here, and we can select from tables just like it was like a local DuckDB instance, right? So you can see I can select from the region table, and look at that performance. Those 5 rows come back really fast, and that's not really impressive, but just a little joke there, a little nerd humor. But let's go ahead and run a query against a larger table. Line item, if you're familiar with the TPCH data model, is the fact table in that data model. So it has all the transaction line items that came in for that online store, let's say. So let's just get a record count from that table. And as you can see, that first of all, that came back really fast. But secondly, it's 600 million records that were counted there. So if you're familiar with the TPCH test suite battery, the query battery, this is query 1, and it's querying line item table with the date filter. It has a group by these 2 fields and has a bunch of aggregates here. So you can hear my dog snoring. That's cool. So I'm going to go ahead and run this query. And as you can see, lightning fast performance. Again, so 600 million records. So that went through all those records, filtered out for ship dates that were less than or equal to that, and ran all those aggregates. So let's take the where clause out. Let's just do the whole table. And as you can see, still sub-second for that performance. All right, so single user, that's okay. And typically, if you're in a DuckDB situation, that's what you're doing. You're running a single user because it's an embedded system. But the cool thing here with Gizmo SQL is we've taken that embedded system and we've made it multi-user. So you can concurrently, with multiple users, multiple sessions, run independent SQL sessions and get lightning fast performance with ACID compliance, all the goodies that you get with the power of the DuckDB engine, but also Aeroflight SQL to secure it, encrypt the traffic, and make it concurrent. All right, so let's go ahead and we have a benchmark repo here, and we're going to go ahead and run a benchmarking suite. So in my scripts directory here, I've got this, let me close this, sorry. I've got this script here that lets me run our benchmark flight SQL Python package. We're going to run each query one time in the TPCH test battery. There are 22 queries in all. We're going to output those to a file, and then we're going to convert that file to Excel, which I'll show you that as well. But long story short, we're not just going to do this one time. We're going to do it 10 times concurrently. And just to give you an idea of how powerful this system can be. So let's go ahead and launch that. And we're going to run with 10 concurrent sessions. And we'll kick her off here. All right, so while that's running, if we go back to our server here, you can see Gizmo SQL is printing out all the queries that come in. from clients. So it's getting quite a few queries because there's 10 sessions hitting it all together at one time. So it's the client is basically beating this server up. And let's get an idea here of how much load is on the system. Here, I'll SSH into the box. And if we run a top, you can see hey, this thing is getting pegged, right? It's got 86% CPU utilization. It's using 50 gigs of memory. It's still got plenty of memory free, which is good. But you can see the top process by far is GizmoSQL Server. And it's using 62 of those 64 CPUs. So we're using all we got here. And that's a good thing. You want to get what you pay for, right? You want to use those resources. All right. Now, while the benchmark is running, let's go ahead and I'll show you an example of the output of that benchmark process. So if we just ran one of these, let's open up, we'll open up this file here. And if we look at the output of one run, this is an Excel sheet, kind of gives you an artifact of what we're dealing with here. So let me set the width of this column. All right, so you can see there's 22 queries in all, TPCH 1 through 22. And you get this column mean runtime. This is the average runtime. We only ran each query once. So you can see that query took 8 seconds to execute. Now, you say, well, that's slower than you showed me before. And the reason is because this is one of 10. So when you run these concurrent processes, of course, it's going to slow down compared to a single user on the system by himself. And that's just a symptom of concurrent utilization with a lot of data going through the system at once. The good news is all 22 queries in this particular example succeeded. There are no failures whatsoever. And they all ran reasonably fast with 100 gigabytes of data. So that's a lot of data going through there, a lot of work by the data engine. And the powerful DuckDB engine is taking care of that for us. All right, so hopefully this thing should be finishing up relatively soon. We can get an idea of where we're at here. You can see these queries come through the system. And talk amongst yourselves. I'll give you a topic. No, it's an old SNL joke. But if you're going through here, you can actually see the SQLs that are getting run as well. So this outputs the SQLs for each of these queries. And you can read through there and execute them yourself if you'd like to. And to get the overall runtime, you just sum this mean column. And you can see that entire benchmark suite took 126 seconds for this one concurrent process that ran. All right, so our benchmark did complete, and it's all done. So all 10 sessions hopefully completed okay. So I'm going to go ahead and run, I got this process called Gantt here, and we're going to generate a Gantt chart that shows the 10 concurrent processes, how they executed, and let's see if they all worked. So we're going to go ahead and run Gantt.py here. All right, so we got some good news here. We went through the 10 JSON files that were output artifacts from the benchmark suite. We had 220 successful queries and no failures whatsoever out of those 10 sessions that were just pounding the database server. All right, so let's look at this Gantt chart. It's a thing of beauty. And let me stretch it here. And you can see we were beating this server up here. And if we zoom in, you can see we indeed were running concurrently and in parallel, right? So we were running some of these queries. Some of them take longer than others. That's just a symptom of beating the daylights out of a database server, which we were doing here. We were running 10 concurrent 100 gigabyte benchmarks on a single machine. But as you can see, we passed with flying colors. All 220 queries succeeded. And we ran this concurrently. And this Gantt chart proves that we were able to handle that parallel workload. And you can see how all the queries eventually completed, right? All right, so how you can learn more about GizmoSQL, go to gizmodata.tech/GizmoSQL. This is our product page. And we get some performance charts here. I haven't benchmarked every system, but as you can see on the left here, we have runtime as the blue bar, and then the right red bar is cost. And if you, we'll zoom in here. So if you look at GizmoSQL, we're not the fastest. I mean, your distributed systems like Snowflake and Databricks, they're going to be faster with this benchmark, TPCH scale factor 1 terabyte, but they're not cheaper. If you look at the TCO, GizmoSQL is dramatically cheaper than Snowflake and Databricks SQL. And this is Databricks SQL serverless, by the way. If you look at Google BigQuery, first of all, get out of BigQuery, come to GizmoSQL. So you can see it was slower and much more expensive in BigQuery. And if you're using an open source system like Trino, and you're using distributed compute when you really don't need to. GizmoSQL is a single instance. It's going to give you less cost in terms of hardware, much simpler architecture, much easier to support. It's a single executable with all the libraries baked in, statically compiled. So it includes Apache Arrow, it's got DuckDB, it's got the JWT library, and SSL libraries all baked into that executable. So you don't have to install any dependencies on your system. So Trino, if you're familiar, is a much more complicated architecture. It's distributed systems. It's installed with Kubernetes, with Helm. It's just much more moving parts, harder to administer, higher TCO just to administer. And look at this performance, right? The performance bar took almost over 750 seconds to execute, and GizmoSQL is well under 250. And Data Fusion, a great open source engine, single node, but the runtime was not nearly as good as DuckDB here. And the cost is roughly the same because it is an open source engine, but the opportunity cost you're paying here by virtue of having a much slower system can be quite high. So we would love to prove GizmoSQL with your data in your environment, in your cloud. The cool thing is with GizmoSQL that you can run in your VPC in your cloud. You don't have to come to us. It's not a SaaS offering yet, and we can make it a SaaS soon. But it is something you can run behind your firewall. You can run on-prem in your cloud. It's going to work on Azure, GCP, AWS. It works on x86. If you want to run it that way, you can run it ARM64. It runs on MacBook. We compile for ARM and x86 MacBook as well. So it's a very powerful system. It's an enterprise-grade, enterprise-class database system in terms of performance, concurrency, security that you will enjoy for years to come compared to your current system. So let us come in. We'll do a benchmark free of cost. We can run with your data, your workload, and see how this thing performs. And I guarantee you won't be disappointed. It's been awesome talking to you. I look forward to talking to you more soon about GizmoSQL and other products that we offer. But check out this gizmodata.tech page and contact us. We can give you a trial license if you want to kick the tires. Thanks very much and have a good day.